Welcome to the Advantech Technical Training. In this opportunity, we will talk about industrial wireless and low power WAN. The outline of this presentation will go through these main topics: wireless networks, global wireless standards, wireless technology according to the frequency band and range, PAN, WLAN, cellular and LPWAN networks, networks architecture, and finally we will give you some guidelines to choose the best wireless technology for a solution. Ethernet LAN versus wireless LAN. In the industry, mainly there are two types of communication to send data: the wired and wireless. The wired uses a cable as a channel to transport the electrical signal or light between two devices. So this method uses collision detection to make sure all the data has completely arrived, and it turns to receive the other's device data. In contrast, wireless communication mainly employs radio waves to pass through the air. This method uses collision avoidance. Once a collision of data is detected, the transmission is immediately terminated, so that the transmitter does not have to waste a lot of time in continuing sending the data. What is the need for wireless communication? There are certain applications where the wire connections are prohibited, or the wire installations are high cost. For these kinds of applications, it is suggested to use a wireless network. Global wireless network standards. Basically, the wireless networks are WPAN, WLAN, WMAN, and WWAN. Let's going to start from the shortest to the largest. WPAN stands for Wireless Personal Area Network. They are short-range networks that use mainly Bluetooth technology. They are commonly used to interconnect compatible devices such as computers, smartphones, tablets, and personal digital assistants. A WPAN has a typical range of about 30 feet. WLAN stands for Wireless Local Area Network. This wireless network uses radio waves. The backbone network usually uses cables, with one or more wireless access points, routers, connecting the wireless users to the wired network. This is the typical Wi-Fi network that we have at home. The range of a WLAN can be anywhere, from a single room to an entire campus. WMAN stands for Wireless Metropolitan Area Network. They are a type of wireless network that connects several wireless LANs. WWAN stands for Wireless Wide Area Networks. This network can be maintained over large areas, such as cities or countries, via multiple satellite systems. They are created through the use of mobile phone signals, typically provided and maintained by specific mobile phone cellular service providers. Wireless network purpose. The wireless networks are designed according to the purpose of the project. On one hand, big data information is so enormous that they're spread across lots of different files and servers. You may have to go through an extraction, reviewing, reduction, normalization, transformation, and other steps to make the information more manageable, and then eventually aggregate your results. With small data, it's usually possible to analyze all the data at once in a single procedure from a single computer file. In conclusion, big data often requires expert interpretation, but anyone can understand small data. This is the reason, nowadays, the devices use networks with devices that allow getting small data that is easily understandable. Wireless technology according to the operation frequency band. On one hand, big data uses 2.4 GHz, and small data uses sub-1 GHz. To understand the benefits of each solution, we will study certain points. 1. Range and performance. 2.4 GHz is not bad in terms of range. You can get 30 meters indoor and 100 meters outdoor. If the application has many nodes spread across a location, then they might like 2.4 GHz. Sub-1 GHz has an advantage in terms of range. You can get 1.3 more distance using the same output power, similar power consumption, than 2.4 GHz. Also, sub-1 GHz signal is well known to bend around buildings, so the penetration allows less degradation of the signal. 3. Interference. 2.4 GHz is a crowded band. Lots of technologies are occupying the 2.4 GHz such as Bluetooth, Wi-Fi, Zigbee, etc. So even though each technology uses different base frequencies and bandwidths, it is expected to have collisions. In the sub-1 GHz are lesser devices, resulting in lower interference. 4. Compatibility. 2.4 GHz has more global standards already deployed in the field, which makes the customers easier to create a product complaint with other vendors. Sub 1G has started to introduce more global standards, but most companies deploy proprietary protocols. 3. Antenna size: 2.4 GHz uses a smaller antenna than Sub 1G. Wireless technology according to the range. For the purpose of the study, we will divide into 4 wireless interfaces according to the range. The first is the PAN network, specifically Bluetooth, which can transmit data in a range shorter than 10 meters. Mainly it is for mobile devices for indoor applications. It is not good for battery long life and for long-range applications. Then, we have WLAN networks. They are similar to PAN networks but with a longer distance for data transmission, along 100 meters. Next, we have cellular networks for long-range applications of about 10 kilometers. It is suitable for outdoor applications because of the capability of long range and long battery life. It is not good for applications that involve a monthly inscription fee. Finally, we have the low-power WAN networks, suitable for outdoor applications and long distance, about 50 kilometers. Likewise, is suitable for applications of long range and long battery life, but it is not good for transmission of high data rates. In the coming slides, we will provide detailed information about low-power WAN networks. Now, we will describe deeper details for the PAN and WLAN networks. Networks for short and middle range. Now, we will describe in deep 3 of the standard of IEEE standard, dedicated for short and middle range data transmission. First, IEEE 802.15.1, known as Bluetooth. It has a maximum data rate of 1 megabit per second for Bluetooth version 1.2, and 24 megabit per second for Bluetooth version 4.0. The second is IEEE 802.15.4, known as Zigbee. It has a maximum data rate of 250 kilobits per second. And finally, the IEEE 802.11 family, known as Wi-Fi. Several wireless networking specifications exist under this banner. The data rate goes from 11 megabit per second up to 1 gigabit per second. Bluetooth wireless standard. This idea was originally conceived as a wireless alternative to RS-232 data cables. Bluetooth is a wireless technology standard for exchanging data between fixed and mobile devices over short distances using short wavelength UHF radio waves. This standard operates at frequencies between 2.400 to 2.485 GHz. This corresponds to the ISM, that is a globally unlicensed industrial radio frequency band. Zigbee wireless standard. Zigbee technology is simpler and less expensive than Bluetooth. It intends to offer a network for easy installation, reliable data transfer, middle range operation, low cost, and a little infrastructure. As a result, these devices are reduced in power consumption and have reasonable battery life. This standard operates at the unlicensed frequency bands of 868, 915, and 2450 MHz. Wi-Fi wireless standard. Wireless LANs have become popular for use in the home due to their ease of installation and use. They are also popular in commercial properties that offer wireless access to their employees and customers. Wi-Fi is a family of radio technologies, commonly used for wireless local area networking, and it has several versions. In 2009, 802.11n was added to 802.11. It offers the best features because it operates in both the 2.4 GHz and 5 GHz bands at a maximum data transfer rate of 600 megabits per second. Most newer routers are able to utilize both wireless bands, known as dual band. This allows data communications to avoid the crowded 2.4 GHz band, which is also shared with Bluetooth devices and microwave ovens. The 5 GHz band is also wider than the 2.4 GHz band, with more channels, which permits a greater number of devices to share the space. Cellular networks. We will talk about the different generations of the telecommunications. Now, we will describe the evolution of cellular communication. Cellular network telephony is a radio-based technology. Radio waves are electromagnetic waves that antennas propagate. Most signals are in the 850 MHz, 900 MHz, 1800 MHz, and 1900 MHz frequency bands. It is useful to think of cellular networks in terms of generations. First, 1G refers to the first generation of wireless cellular technology. These are the analog telecommunications standards that were introduced in the 1980s and continued until being replaced by 2G digital telecommunications. Second, 2G, also known as GSM, stands for Global System for Mobile Communications. The services include voicemail, short message service, SMS, and general packet radio service, GPRS, with data rates up to 100 kilobits per second. Third, 3G, also known as UMTS, stands for Universal Mobile Telecommunications Service. The services include digitized voice, video, and multimedia at data rates up to 2 megabits per second. UMTS offers a consistent set of services to mobile computer and phone users. Because UMTS is built on GSM networks, it enjoys the same global roaming capabilities. Practically all UMTS phones are capable of switching to GSM mode. Fourth, 3.5G, also known as HSPA, stands for High-Speed Packet Access. HSPA is usually considered to be a 3.5G technology because it substantially improves on 3G standards. It is very suitable for mobile web browsing, file downloads, and VoIP. With its high data speeds, users are able to download applications, browsing web pages, or watching streaming video. Traffic will be more concentrated in the downlink than in the uplink. This is the reason why high-speed downlink packet access is normally deployed earlier than high-speed uplink packet access. Finally, 4G, also known as LTE, stands for long-term evolution. The goal of LTE was to increase the capacity and speed of wireless data networks. Potential and current applications include mobile web access, IP telephony, gaming services, high-definition mobile TV, video conferencing, 3D television at faster data rates than 3G. Low-power wide-area network. ISM bands. First, we will explain the meaning of ISM bands because it is a term very used in the LPWAN. ISM stands for Industrial, Scientific, and Medical Radio Bands. ISM band refers to a group of radio bands or parts of the radio spectrum. They are internationally reserved for the use of radio frequency energy intended for scientific, medical, and industrial requirements rather than for communications. Advantages of using ISM bands. Anyone and any device is allowed to use these frequencies, so no license fee is required. Disadvantages of ISM bands: low data rate and probable interference since anyone can use these frequencies. What is a low-power WAN? A LPWAN is a type of wireless telecommunication for low-power wide-area network. It is designed to allow long-range communications at a low bit rate among IoT things. LPWAN technology, including LoRa, Sigfox, and NB-IoT, is suitable for applications requiring low-volume, long-range data transmission while maintaining long battery life, minimal cost, and low levels of interference. Expectations for LPWAN. For the technology of low-power devices, the expectations are: first, long range about 15 kilometers in the open field with ideal conditions. Second, a wide useful life for the battery about 3 or 5 years depending on the frequency and the transmission data rate. Fourth, multi-usage because the same information can be used by several applications simultaneously. And finally, the cost, compared with other technologies. Wireless LPWAN technologies comparison. LPWAN is not a single technology, but a group of various low-power wide-area network technologies that take many shapes and forms. In this slide, we will take the 4 most prominent technologies. LoRa standard works in a frequency band between 433 to 915 MHz with a transmission data rate of 50 kilobits per second. It is designed for outdoor environments and applications. Sigfox standard works in a frequency band between 868 to 915 MHz with a transmission data rate up to 600 bits per second. It is designed for indoor and outdoor environments and applications. LTE-Cat and NB-IoT, Narrowband Internet of Things, standard, work in a frequency band between 7 to 900 MHz with a transmission data rate of 1 megabit and 100 kilobits per second correspondingly. Cat M1 is usually used with sensors in the basement or in the wall due to it has more penetration ability. Cat M1, it has the lowest power consumption and lowest cost with a slow data transfer rate, but it has 1.6 to 10 seconds of latency. It is suited for the environmental monitoring application. LPWAN topology. The main low-power WAN is deployed in a star topology. The end nodes are basically the sensors such as smoke alarms, water meters, etc. The main idea is to connect the end nodes to the concentrator or gateway. The communication between end nodes and gateways is bidirectional, which means end nodes can send and receive data from gateways. The gateway helps to convert from one protocol to another that can transfer the data to the network server. The gateways connect to the network server via standard IP connections and act as a transparent bridge, simply converting RF packets to IP packets and vice versa. The network server is the one to take the data from all the gateways and filter out the duplicated data and store it. Finally, for the analysis of the metadata, we have the application servers. When a response is sent, the network server receives this response and determines which gateway to use to broadcast the response back to the end node. LPWAN data transmission process. Let's see an example of how it works, the low-power WAN network. Let's going to think about a vending machine where you can buy drinks or some snacks. So this machine is transmitting the data about the stock of the drinks. The data of the sensors is taken by two gateways, they send the data to the network server. Then, the application server detects that the vending machine is run out of Sprite. Then, the application server sends back the acknowledge message to the gateway. Finally, the gateway sends a message of acknowledgement to say that it is necessary to recharge soon the storage of Sprite drinks. With this method, it is not necessary to send constant messages, so the devices can save power. LPWAN application scenario. LPWANs are commonly used in applications including smart metering, smart lighting, asset monitoring and tracking, smart cities, precision agriculture, livestock monitoring, energy management, manufacturing, and industrial IoT deployments. LPWANs enable a number of M2M and IoT applications, many of which were previously constrained by budgets and power issues. Choosing an LPWAN depends on the specific application, namely the desired speed, data amounts, and area covered. LPWANs are best suited for applications requiring infrequent uplink message delivery of smaller messages. Most LPWAN technologies also have downlink capabilities. Now, we will explain more details about LoRa, long range. What is LoRa? LoRa, long range, is a patented digital wireless data communication IoT technology. It transmits over license-free sub-gigahertz radio frequency bands like 433 MHz, 868 MHz for Europe and 915 MHz for North America. LoRa versus LoRaWAN, these two terms are easily confused. LoRa is the physical layer in the OSI layer, or the wireless modulation, utilized to create the long-range communication link. Meanwhile, LoRaWAN is the protocol. It defines the MAC communication protocol and system architecture for the network. If we do a comparison with the RS-232 asynchronous communication, the asynchronous means the baud rate, data length, stop bits, etc. Alike, RS-232 is related to physical communication. So RS-232 would be equivalent to talk about LoRa, and the asynchronous communication would be for LoRaWAN. The LoRa devices can be either of these three types. The A devices are powered by a battery. The device is the one that initiates the communication. It sends the data, so the gateway does not have a way to wake up the sensor. This means a saving of power. A typical example can be an alarm when it detects a person only at that moment and sends the data. The B group devices can receive and transmit data at scheduled times. And the C group is the device connected to 220 volts, so it can receive and transmit the data uninterrupted. Application: pipeline data collection with LoRa. This application is using wireless technology to collect the data of the sensors located along the pipeline. The field devices involve gas and water meters and power meters. These devices use Modbus RTU. They are connected to the LoRa end nodes, which communicate with the gateway for processing the data and changing it into Modbus TCP format. Later, it is connected to the SCADA system in the control room. The advantages: hardware-based LoRaWAN private network, supporting Modbus RTU master node, supporting Modbus TCP server gateway. Now, we will explain about Sigfox. What is Sigfox? The Sigfox Global IoT Network operates in several European countries and will begin deployment in the US. The network is designed exclusively for long-range, small-message device communication. Sigfox let IoT device cost, service cost, and power consumption dramatically down compared to traditional cellular or Wi-Fi connectivity. This effectively eliminates existing cost barriers and battery service life constraints for connected device deployment. How does Sigfox work? Sigfox sets up antennas on towers, like a cell phone company, and receives data transmissions from devices like parking sensors or water meters. Sigfox wireless systems send very small amounts of data, 12 bytes, very slowly, 300 baud, using standard radio transmission methods. In these kinds of technologies, the slower you transmit, the easier it is to hear your message. Applications like basic alarm systems, location monitoring, and simple metering are all examples of one-way systems that might make sense for this network. Now, we will explain about NB-IoT. What is NB-IoT? The NB-IoT standard is defined by the third generation partnership project, 3GPP. NB-IoT technology is a narrowband IoT, also known as NB-IoT or LTE-M2, is a proposed LPWAN technology. NB-IoT is a standard that has been developed to enable a wide range of devices and services to be connected using cellular telecommunications bands. NB-IoT deployment on low-frequency bands has more efficiency due to deep indoor coverage. Mostly suggested bands for the technology are 700 MHz, 800 MHz, and 900 MHz. How does it work? The image shows NB-IoT network structure overview. In the example, a smart water meter was installed at home. It periodically sends water usage information via NB-IoT base station to the application server. On another side, the homeowner can monitor and control the detailed water usage information and check statistics on the smartphone. The details come from the IoT application server. The final part, networks architecture. Mainly, we will divide the networks into two types, networks with gateway and without gateway. Short-range radio devices such as Zigbee and Wi-Fi require using a gateway for data transmission. The gateway is typically hooked up to some on-site wired network that is not under the control of the IoT provider. Using short-range radio connectivity complicates the IoT setup due to the implications of wired on-site connectivity, and also due to the settings of firewalls, NAT, port, and protocol filtering. In contrast, using direct long-range connectivity such as LPWAN allows direct access to the devices in the field. The base station typically serves a large number of devices, thus greatly reducing costs. Finally, we may do a question: what is the best connectivity solution? Actually, it depends on different factors. For that, we will make some questions first. What is the scope of the project, and what's the use case? How much data is being sent, at which range, and at which speed in intervals? What is the local context? Is there coverage for any of the mentioned players? Is there other coverage that suits your needs better? Do you build something from scratch as your application will need to work in remote areas? Do you need a hybrid approach with several connectivity solutions, including cellular, Wi-Fi, and more? What about costs? Data range? Outdoor? Indoor? Both? Is there a partnership ecosystem in your area upon which you can rely? How important is the autonomy and battery life of your devices? Etc. Thanks for your attention. Hope this course gave you a basic concept of industrial wireless and low-power WAN. If you are interested in advanced concepts and hands-on, you are welcome to join our product training courses. You will get a return with fruitful knowledge and skills. See you next time. Have a good learning day.